Welcome to the IPv6 Buzz, where we dare to dive into the 128-bit address space wormhole. I'm Ed Horley.
And I'm Nick Baraglio. We discuss everything IPv6 on the show, from strategy, design, deployment, operations, and even internet standards.
And I'm Tom Coffeen. We've spent 20 plus years working with the IPv6 protocol. We work on getting IPv6 working.
And we're here to share some lessons learned and how to avoid common mistakes. We're glad you joined us. Today, we're going to be just going through some listener questions because we've got quite a few of them, and also a quick status update. So I guess we'll start with that. Just a quick note for everyone who's listening by the time this goes in your ears. Google IPv6 stats, the global one, not any of the region stats, but just the overall, will pass 50% threshold. So we had a show, actually, it was the first show that Nick was on as one of the co-hosts. We were talking specifically about, hey, what's going on when we pass that 50% threshold? And here we are. So congratulations. By the time you're listening, we should be well past 50%. Well, not well past, but
fractionally past.
Fractionally past it, so I don't know. What do you guys think? Is there any major impact that we think, or is this going to change the behavior of network and IT industry overall? Do you think it even matters, or are we just going to see the slow grind of V6 adoption and as it plays out, as people figure out that it's something they have to do?
This means we can turn off IPv4 now, right?
Yes.
Okay.
I mean, it's probably obvious, but I think the correlation between me becoming a co-host and that I'm going to take full credit.
As well you should.
No, I think for me, I've been waiting for this, because even if it's a 50.01%, if that's sustained, then that tells me that IPv4 is legacy at that point. And I think it's hard to argue against people saying, well, nobody uses that, nobody asks for that, blah, blah, blah. Well, I mean, over 50% is now IPv6. And so there's pictures you can point at to say, this is why. And here's the reality of things. Just because you may not see it in whatever you're working on every day doesn't mean that it's not a thing, because clearly it is by multiple measurement standards.
Absolutely. And the other thing is that there's a large enough deployment base now that you really do have kind of a late adopter advantage, in that, so many of the vendors that in early days, you couldn't guarantee that there'd be V6 support that worked in the way that you needed it to work. And now with that 50% number represents, a decade and a half, 2 decades of correcting that issue. And so there's never been a better time to start adopting IPv6.
Yeah, the support infrastructure, the capabilities of the vendors, and just the general knowledge of the number of individuals who have some sort of V6 skill set and capabilities is definitely improved dramatically. I think the other thing to note is that this isn't a per country breakdown. Like, as just a quick example, probably the majority of our listeners are probably in the US and in Europe. But if you look at the United States, as an example, it's been well north of 50% for a while. So it's not like that's unique. I mean, France is almost 85%. Germany's at well north of 70%. Even the UK is above 50%. So there's a lot of locations throughout Europe and the rest of the world. I think India is above 70%. So it's just a matter of, your lens, your view, and what impact that might have. So you might be in a country that has very little adoption, but the reality is the overall adoption rate is now above that tipping point. And I think that's an important point for folks that are trying to figure out what impact this will have. Maybe if you're in a large global 2000 shop, you can't really avoid V6 at this point because of what's going on the global footprint basis. So I think it's an important metric just from that standpoint, but I just thought it fun to point out at the top of the show here. Let's switch gears. We'll dive into some listener questions and see what folks have to say. We've gotten a whole slew around sort of, I guess, really sort of home use case conditions. I just wanted to cover maybe a couple of those around sort of like, hey, I want to renumber and I got to deal with renumbering in my home network. And maybe I've got some resources that I'm trying to reach inside my home network. Also, should I be using DHCP v6 or Slack in my home network? So let's lay down some thoughts around where home networks fit and what we think the right guidelines would be for folks that are running home networks. I guess that's a quick and dirty of sort of the general questions. There's probably like 3 or 4 of them, but they're all seem to be in the same vein. So I think starting off, I would just say, don't do DHCP v6 in your home network. There's not really any reason to do it that way. I would say all operating systems support Slack. There's no reason not to do Slack, and all of them have been updated sufficiently to do RDNSS, which is basically getting DNS server information over Slack. And it will pretty much service every single OS that I can think of. to work properly in your network, and you shouldn't have any issues just being able to run Slack in that fashion. I don't know if you guys disagree with that, but it seems to be, and that's what I run for myself here at home. I think both of you do the same.
Yeah, I definitely run only Slack. I fiddled around with DHCP v6 a little bit. And what I found was that, I mean, I fiddled around with it just because I wanted to do it. There was no advantage for me personally to run it. And in fact, you have to run Slack even if you run DHCP v6. And I didn't really see any benefit. It was just extra overhead that I had to, if it broke, like I had to fix it.
Yeah. And why is that? Why did you have to run Slack either way?
Oh, well, because that's how you get your gateway. And, you're going to have all of your systems they're going to have that Slack address anyway, unless can you even turn that off? I don't think you can.
Well, on the RA side, you can force everything to do DHCP v6.
Yeah, that's true. That's the mbit or whatever, but
Yeah, but if you have Android devices or Chrome devices running around your network, they're just not going to function with DHCP v6. They will with PD. So if you want to set up a super complex configuration and run PD and do all of that work, you could do that. That should work just fine. And that would be a heck of a lab.
Yeah.
Stand up and build for yourself. But if you're just running DHCP v6, IANA, which is assigning addresses for hosts, you're going to get a singular address on them. There's not a default client built into Chrome or Android that will do the IANA side. It'll do the PD side, but it won't do the other side of it for just getting a singular address, which means you have to run Slack if you want those devices on IPv6. If you don't care and you're running dual stack, well, they'll function just fine, but you might run into some problems about doing things like, maybe using Chromecast or Chrome Share or whatever to be able to stream services back and forth, or weird name discovery, MDNS issues and things of that nature that you don't want to deal with. You Slack and everything just works. so it's not a problem.
So there's two things, right? The other advantage is that Slack is built to be able to handle automatic renumbering.
Yes.
Right. So when you get a PD, so you're going to run DHCP v6 PD on your CPE device, right? On whatever it is that you've put behind the modem or the ONT or whatever it is, assuming that they're not handling it for you. And then from there, it's meant to be able to handle renumbering of new prefixes. So the nice thing about running Slack at home is I don't have to think about it. Like if my prefix changes, which mine rarely changes, but it has changed in the handful of years I've had it on this provider, I didn't know it and I didn't need to care, right? And that touches on the second thing that I think is probably driving some of these questions is I want to be able to run a server from my house of some kind, or I want to be able to get back into my system from outside. And that's why folks tend to want to have deterministic addressing on the v6 side, right?
Yeah, I think that's a really good point. And I think readdressing was probably the theme that most folks were asking, like, how do I readdress and deal with that? It sounded like a handful of folks were trying to deal with the readdressing of like, I've got a server or I've got like something that I don't want to have to readdress all the time, and how do I discover it? The reality is with Slack, the server can get an address too, so it's not a big deal. And then if you're using, MDNS to find the service, it's just going to find the service based off of the MDNS portion of it, so it's still discoverable. So printers or, any other service you might provide, you can do that. I guess the next extension of that question is for those that are listeners that are probably doing things like, oh, I want my server accessible to the outside world, which is the next phase past that. How do I deal with renumbering for that? And the reality is you probably want a different solution. And it's also probably your service provider doesn't want you advertising services of any type, but from your home network anyway, and maybe blocking that sort of stuff. So there's probably other solutions that make more sense. I don't know if we want to talk through those really quickly. Like I would probably, we've talked about zero tier in the past. That might make sense to do. What other solutions might people think about for getting access?
I use WireGuard VPN to connect to my MikroTik.
Okay.
So for outside access, yeah. And I also have zero tier as a backup.
Got all the bases covered.
Yeah. Belt and suspenders, buddy.
I think that there's probably three use cases that I can think of. You've got, I want to be able to get on-demand access inside my network, in which case zero tier or WireGuard are absolutely perfect. Or you could do, PPTP or IPsec or, whatever it is, some kind of VPN technology into your endpoint over v4 and then get in, and have it hand you v6, or you could have it, connect to a v6 if you have a stable CPE address. Then you have, I want to be able to provide a service outbound. And if that's the case, like if I want to run my blog from my Proxmox server in my basement or whatever it is, right? That sort of complicates things slightly, but it's still fairly easy to run something like a Cloudflare tunnel,
Right.
right? You just run a Cloudflare tunnel. It handles the DNS, it handles the certificate. It doesn't care if your address changes because it's going to handle everything on the CDN side. It's free. I even wrote a blog post on how to do it without V4. So you don't even have to put a V4 address on whatever it is you're running inside there to connect to that Cloudflare tunnel. And that should handle it fairly easily and keep it really stable because, again, it doesn't need to care what the inside, what the internal addressing scheme is. It can be renumbered, it can change, it can move protocols, keep it smarter, not overcomplicated.
Yeah, or just don't host that sort of stuff and use cloud services for what they're intended for.
You can do that too.
That's been outsourced for a long time. So
yeah. I personally use Tailscale to get into everything. I run it on pretty much everything in my house, and I run a system that injects LAN routes.
Okay.
So if I'm outside, I can get to things that don't have Tailscale running on them. And then I have Zero Tier on my MikroTik as a backup. So also belt and suspenders like Tom.
Yeah, I just run my stuff in cloud services, so I don't worry about accessing anything in my home at all. Because all that stuff dials outbound, so I don't care.
Fair enough.
Yeah. So I guess another listener question, sort of tangentially related, was around sort of containers and Kubernetes. And so we got a couple different asks for this, and we heard you. We're getting a guest, so hold on. We'll have a show specifically about that. So I don't think we want to talk about anything specific there, but do realize we have it on our roadmap. So it is definitely something that we are lining up. So I'll let you know as soon as we get one or more guests lined up to talk specifically about that. So thanks for submitting that one.
We're going to have a service mesh of guests to talk about Kubernetes.
One of the other questions was sort of in regards to reputation. So one of the things that was sort of interesting, we got a question about moving everything over to IPv6, but specifically running mail services, converting over your MX records, using public, O365, Proofpoint, other services over IPv6. And is there any concerns about doing that? There was some comments about some security concerns and if things were better in regards to both security and reputation. And I think if you were evaluating this 2-3 years ago, maybe you would have a little bit more difficulty. I think especially now the geolocation data is incredibly good about IPv6. So there's a lot better reputation and geo-reputation information available for IPv6 from any of the reputation providers. So you're definitely going to have sort of a better setup. Google, Yahoo, all the major email providers have been running natively on v6 for a long time. So the reputation side should be very well established in terms of who they connect to. And as long as you have your MX records, you've got, whatever your DKIM and all the other protections in place for dealing with mail and reputation, you should be good to go. I don't see any reason why you would not do that. And in fact, what you can do just on the MX side, right, is start preferring from an MX ranking basis, you could still prefer your v4, start putting your v6 records in there. And if people are speaking v6 only, they'll deliver to you via v6 because that's how that works. You can start seeing the traffic and testing with the reputation portion around that. And then you can just change your MX ranking records to start taking more and more traffic on IPv6 as things progress. I don't know if that would be a reasonable strategy, but that's probably how I would tackle it if I was concerned about being able to test and see reputation for certain things. But it would get you on the map in terms of v6 to start being able to actually take inbound and deliver outbound v6 related email. So that's sort of my quick thoughts. Tom, Nick, do you have anything to add?
Yeah, I was just the general comment about reputation data and geolocation data in particular around IPv6. I was surprised to discover that it's improved significantly in what seems to me a very short period of time. I haven't been checking with geolocation accuracy, on a regular basis, not sort of the space that we play in general. But was pleasantly surprised to find that so much progress had been made in that area to make the data so much more accurate.
Yeah, I've been pleasantly surprised about looking at the granularity of some of the data that's coming out from that. It's definitely improved.
Yeah, that was a bit of a surprise to me. The last time I looked was probably 2.5 years ago. And some of the things I was looking at didn't have it yet. And that sort of deterred me from wanting to move over to it. And I'm glad to hear that that's improved because when I started, I haven't been a mail admin and it hasn't been long enough, but it's been a long time because that's a hard job. Very hard job.
There's still some sendmail.cf files floating around in your hard drive somewhere.
So much of that. So much. But I'm glad to see that that's been improving. I mean, that is, I think, going to help drive that over 50%,
Yeah.
as the clients have it. And now, all the MXs are going to have it. And that's a lot of traffic. People love email.
Yep.
I'm not quite sure why, but they do.
Well, I guess additional question that we got was a question about covering stuff with NAT66. And I feel like we've covered that quite a bit in terms of sort of NAT translation. We've covered both MPTV6, which is network prefix translation, which is basically having matching prefixes on both sides. So you would have a 48 on one side, a 48 maybe on the inside, and you're translating between the 48 to the 48. It's all one for one. So it's stateless, very fast, very efficient. It's a nice capability. And then NAT66 is going to look more like traditional NAT44. But maybe we can offer some caveats around vendor implementations around NAT66 to sort of answer some questions there really quickly, because right before we hit record, we were chatting and Nick didn't actually know a couple of the things that Tom and I had mentioned, which was, hey, some of the vendor implementations use NAT66 commands to actually accomplish MPTV6, and specifically on Cisco devices and iOS. And if you're running the older ASA code, you're going to use NAT66 commands, even though you'll be configuring something that looks like MPTV6.
Well, I don't have a lot of modern experience with Cisco gear, but John Howard wrote a really nice blog on how to do MPTV6 on Vios. And I was reading it and I was like, wow, this is really useful. But it was kind of irksome to me because the commands were all NAT66. And I was like, in my mind, that was not right. But he was like, I don't know, that's what it calls it. Because I was asking him about it. And then you guys were telling me, well, Cisco does that too. And I was like, well, because MikroTik calls, I don't think it calls it NAT66, but it calls it IPv6 NAT, but then they use something completely different for NPT. It's like a netmap command to do that.
Yeah.
Right.
So there's lots of different terminology, and I think a big part of that is probably because it's
not a standard.
Kind of left to the vendors, right? It's not standardized.
I think what we have, Palo Alto actually calls it NPTv6.
Palo Alto definitely calls it NPT, yeah.
It implements it as NPTv6.
Yeah, that's where the majority of my experience comes from, is the PAN side.
Yeah, and MPTV6 is only listed as experimental, if I remember correctly, right, Nick?
This is correct.
So if folks aren't happy with those standard settings, maybe you should write a few emails to the V6 Ops working group and say like, hey, we need better standard written about NAT66 and about MPTV6 because they're tools that we need in our tool belt. So could you please, write those up as standards to help the vendors get more consistent implementations done about it? Wouldn't be a bad thing. Oh, not that we haven't tried to tackle that before, but hey.
We did get the great Fred Baker to update the code that's in the current RFC that does not handle ICMP. So there's some pieces of ICMP that aren't handled correctly, and he did fix that. So there is a draft out there that has that information in it.
Yeah, I would say the other thing maybe consider is what you're trying to accomplish with MPTV6 versus NAT66. I mean, if you imagine a scenario of using IPv6 in the same way that you've used IPv4 over the years and essentially overloading a single IPv4 address, a NAT overload, you're probably thinking of NAT66 in a similar way, versus another configuration scenario where you're using NPTv6 to translate from one, as you mentioned, Ed, one prefix to another, and a one-to-one translation, between the prefix address space and the addresses within it. They're solving sort of different maybe use cases depending on what you're trying to do.
Yeah.
And so you kind of have to look at it from that perspective of which of these tools am I really after? But then, of course, the caveat is that what the vendors have actually implemented may not conform to what you ideally would like to see for the architecture and the configuration that you're trying to put together.
Yeah, that's the issue. I mean, I see value in NAT66 for one specific reason, that MPTV6 requires a matching of the prefixes. And you may run into the use case where you want to run a 48 inside your house, but maybe your provider is only giving you a 52. It becomes problematic of like, oh, do I only want to allow portions of my network to get outbound with MPTV6 and match that up 64 to 64 for every single one that you might be implementing? You're going to run out at a certain point, right? Because it's not a one-for-one match for the total size of the prefix, to be specific there. And with NAT66, you could be like, okay, well, I'll take, these following sets of prefixes and bundle them together and overload into my existing. It's not like you need addresses. That's not an address thing. It's really how many prefixes can I map through? And you should have plenty of addresses to be able to map through even in a 64, right? You're not going to run that many internally. So if you can control the mapping, it becomes a useful tool the fact that the IETF wants to stick their head in the sand and not recognize that as a useful tool or function for certain use cases seems a little ludicrous, especially for things like local internet hop off, even for enterprises like SD-WAN solutions, things of that nature that maybe you are only using, PA space from Comcast and Spectrum and everyone else because all your remote sites are running around with those. So realistically, you have to translate. Maybe you do have a PI block and you're running that internally, and that's going over the overlay for SD-WAN to get to that remote site. And you only number with that PI space in the remote site, but you have to translate it to the PA in order to do local internet hop off. It would be useful to have a NAT66 tool that's standardized by the ITF to say, hey, this is a use case. It makes sense as a use case, and we want this to scale up, and we want it to be consistent amongst our vendors. But today, the consistency requirement can't be there because there's not a standard, which is, I think, problematic. But that's just my opinion. So, take that with a very small grain of salt.
I mean, a devil's advocate, maybe there would be a lot more sort of NAT66 deployment out of a lack of understanding of what you can do with IPv6. And folks just like, hey, this is how we did it in V4. This is how we're going to do it in V6. And I would get on with my life.
Click the button.
Yeah, exactly.
That's definitely a concern.
I don't think you're going to get away from that particular problem, regardless of what happens, because the vendors are going to build the solutions either way. And so you're going to be stuck with whatever implementations they do versus something standardized. That's the counterpoint to that counterpoint.
I mean, we're kind of in that situation already, right?
Yes.
Also, theoretically, that it was probably more of a risk back before there was a significant amount of IPv6 deployment. And now you can, as an IT architect, an enterprise architect, you can point to deployments that don't use it, that are using IPv6 correctly. There's enough of those around that maybe not as much of that risk of just reflexively adopting IPv6 using a NAT66 model in the same way that you use NAT44.
Right. I would also argue probably the major footprint for V6 are more sophisticated shops who understand the nuances about what we're dealing with here, and that the remainder falls into probably the, home, small to medium, even medium-sized businesses that are probably going to have to leverage NAT66 anyway, given their footprint. They probably aren't going to register to get a ASN and get their own PI block at scale and want to do BGP everywhere, et cetera, et cetera, et cetera.
Yeah.
They need that tool in the tool belt. Until they get it, they're not going to deploy. And so the real question is do we want to accelerate the second half of the deployment of V6 in a useful way? And so that becomes more interesting.
I think the BGP model doesn't scale from a disaggregation and route table size standpoint anyway.
Yeah.
Right. That's always a concern, right? There's too much disaggregation and the route tables are huge, and we already have like 1 million routes in the V4 table that we got to carry. So, I mean, I think there's a problem there. Now, let me propose a radically different answer that is probably longer term, but I would argue better than all of them. And if you go digging through my GitHub, you can find what I'm talking about because I've written a draft that is yet to be submitted, and there's also some code that I wrote that does it. And that is, we don't care about any of these things. Address translation can just go away because the proposed idea is that the host handles source address and dest address based on best performance. Because it doesn't do this currently. And it's essentially a little bit heavier weight, happy eyeballs at the host level, right? So you can have multiple prefixes from multiple providers. It doesn't care if they're PI or PA. It does a couple of different tests and figures out what the best pairing is, ranks it based on, right now, the code that I wrote, ranks it based on RFC 6724 update, and then basically tells you like the top one is the best performing path.
So a remote site would run the PI block that you have over SD-WAN to get to your site, and they would know to reach anything in the PI block. That's use that preferred interface. And then you would also run and advertise a PA block for everything internally. And it would know, okay, if I want to reach external resources, I can pick and choose based off of performance characteristics or based off of what I advertise as reachable routes via RA, right?
Yep.
And do that way, which is totally doable. Yeah, makes sense to me. If you're interested in looking more details, the updates or the soon to proposed updates for RFC 6724 are a good read in terms of seeing the kibitzing back and forth and understanding about what's going to happen. There's going to be some complexity that goes in that helps to fix the ULA problem and several other problems that were identified along the way. So it's worth some time doing that. And if you're really interested, you can reach out to Nick directly because he got stuck writing it.
I mean, I helped.
So, I was like, oh, look, there's a problem over here. Ed discovered a problem and they handed it to Nick to go fix.
I was the Vader to your Palpatine.
Anyway, so I think we covered most of them. There was an additional question of saying like, hey guys, can we get some more information about PathMTU? Just know we have it on the schedule for a IPv6 Buzz Basics to do PathMTU discovery. So it's on the calendar. So keep an ear out and you'll get that one soon enough. So I think that covered them all, right?
Keep sending them in.
Yeah, keep sending us questions. And if we're wrong, definitely tell us we're wrong, even if it's just your opinion and you think we don't know what we're talking about. That's all good too.
Yes, indeed.
All right. Thanks, everyone. Thanks for joining us for this episode of IPv6 Buzz. If you've got feedback or follow-up on this topic, send us a message at packetpushers.net/FU, where FU stands for follow-up. We'd love to hear from you and continue the conversation.
Also, at packetpushers.net, you'll find a range of other deep dive technical podcasts for IT pros.
There's a whole lot more on the Packet Pushers site as well, such as tutorial videos and a community Slack channel where you can talk with industry peers and experts. So whether you're deep in your career or just starting up, Packet Pushers is the place to go to grow both your skills and your personal network.
So long and until next time, we'll see you on the IPv6 internet.